Hello, hi, good evening, good afternoon, good morning, depending upon what time of day you're watching this video. It's all up to you, right? Great. So, welcome to another lecture. In last lecture, what we have done? We have solved some questions based on graph, right? So, today, what we are going to do? Today, we have done that. So, today, we have to do something different, right? Yeah, we have to change. Change is the only constant. So what do I do? Too much of lip balm. Sorry. Okay, not an issue. Fine. So what we are going to do is I'll do whatever I feel like. You know, because I don't know. It's my channel. I do whatever I feel like. So I feel like doing few more questions, but not based on the standard graphs that you have seen: velocity time, acceleration time, position time, displacement time, though all those we have covered. So what we are going to do now is we are going to do some miscellaneous graphs. Okay, we are going to do some miscellaneous graphs. So that will be a good thing to do. And based on that, we'll see some questions. Okay, so next we have certain miscellaneous graphs, right? Okay. Miscellaneous graphs, right? Okay, great. Now let us see how to do this. Fine. So what are the miscellaneous graphs? Miscellaneous graphs in the sense, apart from position time, displacement time, velocity time, acceleration time graphs, we could get some other type of graphs as well. Like for example, the first one we have is Vx graph. Okay, first graph that you'll see is Vx graph. Right, so what happens in Vx graph? So in Vx graph, let me adjust this podium a little bit. I'm getting a little bit of movement here. Right. Right, not an issue. It's fine. Okay. So Vx graph. So in Vx graph, we have a graph between velocity and position, right? So if we have a graph between velocity and position, what can be done? That is what we have to see here, right? So suppose we have a Vx graph like this. The graph will be something like this. Here on x-axis you have x, on y-axis you have v. So we have Vx graph, right? Right, great. Okay, it happens sometimes. Okay, not an issue now. Now let us see what we can do here. So what can we find from Vx graph, right? Someone is trying to disturb. Right, great. Okay, so what happens in Vx graph? Let us try to understand. In case of Vx graph, what we can find from here? What will the slope give? Slope is what? dv by dx. Is dv by dx any meaningful physical quantity? No, dv by dt is acceleration, but dv by dx, velocity gradient, we don't, means there is no quantity as such apart from velocity gradient itself, you can say, right? Fine, so dv by dx, nothing. Area, what is velocity into position? I cannot think of any meaningful physical quantity. Can you think of? So as far as I can understand, the slope or the area is not going to give us anything meaningful. Then what can we find here? So see here, we have one relation. Acceleration is rate of change of velocity. So acceleration can be written as dv by dt, right? Acceleration can be written as dv by dt. Clear? Any confusion here? No, right? Now here we have Vx graph. We don't have Vt graph, we have Vx graph. So what is the further change that we can do? So the further change that we can do here is we can write dv by dt as dv by dt can be written as dv by dx into dx by dt. Fine. We can write it as dv by dx into dx by dt. Now what change will that bring? So see here, this is something we can do. So differentiation, you may or may not be knowing. If you have not studied it till now in your school, then you may not be knowing much about it. So after this, I'll be teaching differentiation. Anyhow, what I'm doing is I'm kind of applying chain rule. So I can split dv by dt like this. I can write dv by dt as dv by dx into dx by dt. So in a way, you can say that dx gets cancelled and we'll get same dv by dt again, right? Now, so basically I can write this, because if we simplify this, you are going to get this thing again, right? So what happens now is dx by dt is nothing but velocity. Dx by dt is nothing but velocity. So acceleration can be written as v into dv by dx. So this relation you might be knowing or may not be knowing. So later we will have like general analysis of motion, or you could have calculus based questions where questions can be based on integration or differentiation. That kind of question could be there. So there you will see that acceleration can further be written as v into dv by dx, right? Something like this. Acceleration becomes v dv by dx. Now what is v? V is velocity and dv by dx is nothing but slope of Vx graph. Yes or no? dv by dx is nothing but slope of Vx graph. So from here, from this particular graph, so if we have any point, and if I take any general point on this graph, suppose if I take a point whose coordinate is some x1 comma v1, fine. So from here you can see acceleration, you can actually figure out acceleration from Vx graph. Okay, from Vx graph you can figure out acceleration. How can we figure out acceleration? So acceleration at any point, okay, acceleration at any point will be the velocity at that particular point. Acceleration at any point will be velocity at that particular point into slope. Okay, velocity into slope, that's what I'm saying. Okay, acceleration at any point becomes simply velocity into slope. Okay, so like for example, here if you need velocity at x1, sorry, acceleration at x1, then it will become v1 into whatever is the slope. Slope is tan of the angle theta, right? So if we have Vx graph, acceleration at any point will be velocity at that particular point, right? Acceleration at any point will be velocity at that particular point into the slope, right? Clear? So this is again an important point that you need to keep in mind. Okay, right, great. Let us see the next one. After Vx graph, the second one that we have is another important graph, which is Ax graph. Right, what is Ax graph? Ax graph is if you have a graph between acceleration and position. If you have a graph between acceleration and position, then what can you do from it? That is what we need to understand here, right? Fine, so Ax graph means something like this. So here on x-axis you have the position, on y-axis you have acceleration. Okay, on x-axis you have position and on y-axis you have acceleration. Fine, so the Ax graph, let us say this is your Ax graph, just the graph I have taken, right? Now we need to understand here what can we find from Ax graph. What will Ax graph give us? What exactly can be calculated from here? Again, slope will be dA by dx. So that is simply acceleration gradient. That is again not any meaningful physical quantity, right? So dA by dx is not going to do it. Area, if I try to find area under acceleration position graph, so that becomes integration A dx, that becomes integration A dx. So area under acceleration position graph will also not give us any meaningful physical quantity, because acceleration into position, what is exact? You understand what I'm trying to do here? Whenever you have slope, you can roughly divide to figure out what exactly you are trying to find. So slope is like division and area is like multiplication. So acceleration by position, we don't have any quantity. Acceleration into position also, we don't have any quantity. So what exactly we can find here then? So see, again we'll go back to that calculus relation that we have just seen. We have seen that we have this formula, acceleration can be written as v dv by dx, right? Acceleration can be written as v into dv by dx. Fine. Now from here, if we simplify v dv, from here if we simplify, v dv becomes a dx, right? V dv becomes a dx. V into dv will become a into dx. Now what you do, you integrate on both sides, right? So integration v dv will become integration a dx. Fine. Net integration v dv becomes integration a dx. Now what is integration a dx? Integration of acceleration with respect to position. So that is going to give you area under the graph. Integration a dx is nothing but area under acceleration position graph. So this part, integration a dx becomes area. Now you integrate this part, you put limit for this part, for this v dv part. So lower limit will be u, lower limit will be u and upper limit will be v, right? Lower limit will be u and upper limit will be v. So if you simplify this, this becomes v square by 2, right? Integration v dv becomes v square by 2 and the limit will be from u to v, right? Limit will be from u to v, and integration a dx is nothing but the area under acceleration position graph, right? Integration a dx is nothing but area under acceleration position graph. So from here, if you simplify, what will you get? Area will come out equal to v square minus u square by 2. Fine. V square minus u square by 2. Right? Okay, great. So this point you keep in mind. If you have acceleration position graph, area under acceleration position graph will give you v square minus. So everything cannot be given, but some specific things are there. That is why this is miscellaneous or one-off case that we are talking about here. So if you have acceleration position graph, if you find area will give you v square minus u square by 2. Final velocity square minus initial velocity square whole divided by 2. That's what you're going to get here, right? Okay, great. So just keep that point in mind, right? Keeping that point in mind, we can move ahead now. So area becomes v square minus u square by 2. Great. Amazing, awesome. That's all we can say. So if you know initial velocity, you can find the final velocity at any instant. At least the speed you can find. You cannot find the direction because we have square. So it's like final speed square minus initial speed square by 2. So if you know the initial speed, you find the area and that will give you the final speed. From this relation, by equating this, you can find the final speed, right? Okay. Let us see the next miscellaneous graph, the third one. The next miscellaneous graph that we have is, what do we have? Next miscellaneous graph is acceleration position. After acceleration position, there is a graph which is v square s graph. Okay, next we have v square S graph. Fine. So if you have a graph between V square and S, what are we going to get if we plot a graph between V square and S? Right? Fine. So this is V square and this is S. So the graph will be something like this. Means, now the thing is that again, this is a very specific case. Okay. So we can find something through V square S graph for a particular case only. That particular case is like earlier, here there was no case. There was no case in the sense, you know, the graph can be anything. The graph need not be a straight line. It can be a curve or anything. Still these relations are valid. But this one is valid only if it is a straight line. Okay. This concept that I am discussing is valid only if it is a straight line. If it is a curve, we cannot find anything meaningful from this particular graph. Okay. Or maybe we can, I'm not sure, but generally just for this specific case, when the graph is a straight line, we talk about this. Okay. Fine. So valid for straight line, you can say. Valid for straight line, right? So what can we find from V square S graph? So you might be knowing the equation of motion, right? Generally we study three equations of motion: V equal to U plus AT, S equal to UT plus half AT square, V square equal to U square plus 2AS, right? So if you remember, one of the equations is V square is equal to U square plus 2AS, right? One of the equation is V square equal to U square plus 2AS. Now what we can do is we can modify this particular equation. Okay, we can modify this particular equation and we can write it as V square equal to 2AS plus U square. Fine. Now what you can do? Now you compare this equation with y equal to mx plus c. Right? You y equal to mx plus c. Now you compare this. If you compare, what will you get? M will get compared to 2a. Right? So m is nothing but slope in this particular graph. In this particular equation, m is nothing but slope and c is y-intercept. M is slope and c is y-intercept. So what will the slope get compared to? So the slope m will get compared to 2 times a, 2 times acceleration. So slope here, slope will be equal to 2 times the acceleration, right? Slope will be equal to 2 times the acceleration. So from V square S graph, what can you find? You can find acceleration. So acceleration will be half of the slope. So whatever is the slope of this particular graph, half of the slope will give you acceleration, right? Half of the slope will give you acceleration. So that's that, right? Okay, great. So half of the slope will give you acceleration. What will the y-intercept give? So y-intercept is basically the point where this thing is cutting y-axis, this length c, right? So what will this length give? Let me delete this as well. So this length is c, right? Fine. So you compare, what will the y-intercept give? So y-intercept will give you u square, c will give you u square. So you can find the initial speed. Initial speed will be under root of the y-intercept. Okay, the initial speed here will be under root of y-intercept. Since c is u square, so it will always come out as positive only. So under root of y-intercept will give you the initial speed. Y-intercept. Fine, so that's the point here, right? Clear? Any confusion? No confusion. Great combination, right? Fine, we'll go for the next part now. Great. So this is all you have in graph, and now we'll see some question and we will call it a day for this session. Okay, next class we'll start with differentiation and all, right? Fine, see this question. Right. So now these are some questions. So question number 1, let us see. Let us try to apply the concept that we just studied, right? Are you able to see the question? Right? No problem there, or is there any problem? Right? There should not be any problem because I have solved your problem, right? Okay, great. Let us see what is happening here. Question is saying something, and just give me a moment, just one moment. Let me check if there is any problem with the battery, and there is a problem. Let me power it up. Things could get problematic. Right. Great. No confusion. Great combination. Okay. Let us see now. Let us see what is happening. Fine. So we have a graph between v square and x. So they are given a particle is moving with a constant acceleration a. Following graph shows v square versus x. V square versus displacement plot. The acceleration of the particle is. So we just studied the concept related to this. We just now, just at this very moment, we studied the concept related to it. What is the related concept here? So the related concept is that this is v square and s graph. Direct application. This is the graph between v square and s, and you can see this is a straight line, and we simply need the acceleration. Now what will be the acceleration? So acceleration, how do you find from v square s graph? So acceleration is simply half of the slope, right? Acceleration will be simply half of the slope. So slope by 2. So that is your acceleration. Acceleration is simply half of the slope. So how much will be the slope of this particular straight line? How can we figure out the slope? So see here, let us take a line like this. Yes or no? So we need slope of this line. Slope is basically tan of the angle theta that it makes with positive x-axis. Tan of the angle theta that it makes with positive x-axis. Suppose this angle is theta. We just need the tan of this angle theta. Tan theta by 2, right? Tan theta by 2. Now how much will be tan theta value? How can we figure it out? Quickly, tell me how much will be this length? How much is going to be this particular length? This particular length will be 80 minus 20, which is 60. So this length here will become 60. So that's Great. And this length here will become how much? 30. This length will become 30, right? So this is 60 and this is 30. So that is what you have here. Now, so tan theta by 2, how much will be tan theta? Tan theta will be 60 by 30. How much will be 60 by 30? 60 by 30 becomes 2, right? So tan theta basically here will be 60 by 30. Let me do it here itself. Whole divided by 2. Now 60 by 30 is 2. 2 divided by 2, which will be 1 meter per second square, right? So answer here will be 1. Fine, right? Okay, great. Fine, so understand how to apply the concept that we just studied. If you have v square s graph, acceleration will be simply half of the slope, right? Acceleration will be simply half of the slope. Great, amazing. Let's move on. Let's go for the next question. What is the next question? Do we have the next question or not? This is the next question, right? Next question is question number 2. Question number 2. Clear? Now what do we have to do here? So like when a particle is moving along a straight line such that its velocity varies with position as shown in the figure, then the acceleration of the particle at x equal to 10 meter is. So they have given Vx graph, they have given velocity and position graph. From this velocity position graph, we have to find acceleration. Okay, from this velocity position graph, we need to find acceleration at x equal to 10. We need acceleration at x equal to 10. Fine. Great. Amazing question. How to solve this? Question is great. That's the greatness of the question maker. But our greatness will be seen in how we solve this, right? Okay. How to solve this question? Very, very simple. We have just discussed the related concept. If we have Vx graph, acceleration is simply v dv by dx, which is velocity into slope, right? Velocity into slope becomes the acceleration. So from this particular graph, we need to first figure out how much will be the velocity at x equal to 10, right? Let me keep this as equation 1. So let us first find velocity and slope, and then we'll put it there. Now how much will be velocity at x equal to 10? Is x equal to 10 a midpoint? No. So we cannot apply the midpoint concept. How can we calculate? So there are many ways in which you can do it. You are a math student, you know maths much better than me, right? So here, let me take a point. Suppose this is corresponding to x equal to 10. So corresponding to x equal to 10, there will be some velocity v. And corresponding to x equal to 10, there will be some velocity v, right? Now what we can do? How can you find this? So what will be tan theta? Tan theta will be, say this length is 15. This length is 20. Right? Now here, this length so how much is this length? This length will be 10. So see, the point is, or you can simply equate the slope. Why to do this much? to do whatever way you want. So basically I was trying to equate tan theta from this smaller triangle and the bigger triangle. So that is one way to do it, or you simply equate the slope. So whether I find slope from these 2 points, so like let me put the coordinates of this point will be 15, 0 and this point will be 0, 20. So if I find slope using any of the 2 points, it should be same because they are all lying on the same straight line. So let me first find slope using these 2 points. So y2 minus y1, so v minus 0 by x2 minus x1, that is 10 minus 15, and that will be equal to, if I find slope using these 2 points, it should also be equal to that. So y2 minus y1, that is 20 minus 0 by x2 minus x1, that is 0 minus 15. So v by minus 5 will be equal to 20 by minus 15. So minus 5 minus 15 will become 3. So v will become 20 by 3, right? So velocity at x equal to 10 is 20 by 3. So this becomes equation 2. Now we need to find the slope. So slope, again tan theta you can do, not tan of this angle theta, we have to do tan of this angle theta. So slope here will be actually negative because you can clearly see that this angle will be obtuse. So tan of this angle theta will actually give you slope, right? But what we are going to do is I'll just find the slope from these 2 points. So if you have any 2 points, slope will be y2 minus y1 by x2 minus x1. So 20 minus 0 by 0 minus 15, as simple as that, right? Why to complicate things? By what? 0 minus 15. So that becomes 20 by minus 15, right? How much will that be? So divide 5, 4, 3. 4 times 20 by 3. So minus 4 by 3. This is the equation 3. Fine. Now what you are going to do? You use equation 2 and 3 in 1. Okay, we'll use equation 2 and 3 in 1. Okay, so if we use equation 2 and 3 in 1, acceleration will come out equal to velocity, which is 20 by 3 into the slope, which is minus 4 by 3. Fine. So minus 80 by 9. And how much is that? So 9 8 is 72. So close to minus 8.9 meter per second square. Fine. So answer here will become the third option, right? Clear? So I hope you understood this. No confusion anywhere. Everything is fine. All is well. So everything will be well, right? Okay, great. So I'll keep the session till here for this particular lecture. So now we have completed the graph part completely. Again, if you have acceleration position graph, similar kind of thing you can do. You can find the area, and area will be equal to v square minus u square by 2. Okay, I couldn't find any question related there, but it could be framed. So means there must be, I have to search more, but I did not have much time, so we'll keep it till here only, no problem. You just keep the concept in mind, right? So what you're going to do now is, so moving ahead in motion in a straight line, there will be a lot of application of calculus part. So especially the differentiation, integration, maximum, minima, these concepts will be used a lot. So what we are going to do is, we are going to study those concepts first before moving ahead further in this particular chapter. So in the next class, we are going to start with the basic calculus, which is very, very, very important for you to understand or to solve problems in the coming topics, right? Okay students, thank you. So I'll keep it till here. Keep learning, keep